Okay, so compound inequalities, we're going to take two inequalities and put them together. A compound is like a collection of things, okay? Like, yeah, like a collection of things in general. I know. Well, all that came to mind was compound W, and then I was trying to think in my head what that is. Isn't it for, is it for wards? I don't even know. This is what popped into my head. Okay, we'll leave that one alone. Anyway, so compound being we put things together. Or like, you know, there's like a military compound, which is a collection of buildings and different services for the military and their families. Compound.
There you go.
Group of things, okay? So we're going to talk about compound inequalities, which are a group of inequalities put together. They're either separated by the word or they're separated by the word and in math, those words have very distinct meanings. Okay, sometimes in everyday language we toss them around and you don't think much about what you're saying, and sometimes you might even use them interchangeably just in casual conversation. But this is one of those times where there's a word that we use in casual conversation that has some very specific meanings in math. Okay? So, stand up if you have a pet at home.
Does the sibling count?
No, siblings don't count. Okay. So you got a pet at home. Okay, go and sit down. Okay. Stand up if you're wearing white somewhere. That might be a bad one to use. Okay. Sit down. Okay. Now, stand up if you're wearing white or you have a pet at home. So one of those has to be true. Here's a hint. If you stood up already, you should be standing. Okay. Now, stay standing if you are wearing white today and you have a pet at home. Okay. So do you guys see the difference between or and? So or, yes, sit down. So or is like one or the other. It doesn't matter. One of them has to be true. And it's got to be both that are true. Okay. So coming back to our inequalities, we've got two inequalities here. 2x is greater than or equal to 3, or 2x is less than 1. Can you guys find some values that would work for these? This compound inequality? As a hint, since it's or, you just have to find something that works for one of them. If it works for both of them, fine, but it just has to work for at least one of them. So, could we simplify these and solve for x maybe?
Yeah.
Let's go ahead and do that. We don't use a ton of words in math, especially when we're solving equations or inequalities, but this is a time you have to use a word. You got to write the word or, because it's an important part about the problem. Because if you don't write or, then there's that ambiguity, like is it or, is it and, I don't know. Okay, so it's got to be in there. Today won't be as big of a deal, but on Wednesday we're going to be using this in a different context. And you need to remember to use the word and or. Okay? So let's see, if we solve for x here, divide both sides by 2, we get x is greater than or equal to 3/2. Or, divide by 2, x is less than 1/2. So can you guys shout out some numbers that work for this inequality, this compound inequality? 5. Because it fits on this one, right? It's greater than or equal to 3/2. Does it work on this one?
No.
5, no. And that's okay. If since it's an or, one or the other has to be true, not both of them. Okay, what's another number that works? 4. Works for this one, right? What else? -1 works for this one, but not this one. And that's okay. It's an or. Okay, so all of those are solutions. Now let's talk about an and. So with the and, this is the one that's a little bit pickier because they both have to be true. So whatever numbers we come up with has to satisfy both inequalities. So if we were to solve this one, subtract 2, 2. We add 1 on the other one, Okay. So we have x is greater than or equal to 1 and x is less than 6. Can you guys give me a number that's a solution? 5. Is it greater than or equal to 1? Is it less than 6? Okay, so 5 is a solution because it meets both inequalities. What else?
I actually have a question.
Okay.
Can you like put it together so it has like the x in the middle and then the inequality sign on either side?
Yeah. So if it's between two values, you can write this 3-part inequality. I got some notes coming up on that. Yeah. Okay. What other numbers would work? 1. Is it greater than or equal to 1? Yeah. Is it less than 6? Yeah. What's a number that's not a solution? 7? I heard 7. Is it less than 6? No. Is it greater than or equal to 1? 7 is. But since it's not a solution to this one, it's not a solution to the compound inequality. So it has to be a solution to both of them if it's an and. Okay. Okay. We're going to look at graphs a little bit. We didn't the other day. My hope is that it's familiar to you and you need just a little bit of a reminder. Okay. So we're going to graph a compound inequality. So x is greater than or equal to 6 or x is less than 0. Okay. It's an or, so both inequalities are true, part of the solution. Okay. So x is greater than or equal to 6. Coming into Math 95, you should have graphed inequalities before on a number line. You may or may not have graphed them the way that we do here at PCC, so I'll give you guys a little bit. I shouldn't say we here at PCC. It's not just PCC. Okay. So in if you're introduced to inequalities before, you might have had something like this, where you use either an open circle or a closed circle. Yeah? Okay. So since we're working towards some notation, we are actually going to use the same things we use for interval notation. Okay? So if we have an open circle, instead of writing it, we're going to have a parenthesis. Okay? And instead of a closed circle, what are we going to have? Square bracket. Now for the sake of having some complete notes, if it goes the other way, then the graph looks like this. So see how the parenthesis and the square bracket open in the direction the arrow is going? So we'll be using these. Are there questions about that? You can see nice pretty number lines in your book. Mine will be adequate when I draw them. Okay, so x is greater than or equal to 6 or x is less than 0. So we're going to find 6 and we're greater than or equal to, so we're going this way, and it's or equals to, so we're going to use a square bracket. You shouldn't have a second line above the number line. You should be coloring directly on top of it. And if you're just using pencil, you might have to just shade it really good or grab a pen. And then the other one, x is less than 0. Less than, which means we're going to the left. And it's not or equals to, so we're going to use a parenthesis. Okay. Now we're still working on notation, so let's talk about interval notation. How many intervals do we have here? There's 2 parts to our graph, right? So we're going to have a U that chunks the 2 together, okay? So if you've done unions before, there's unions and there's intersections. Unions are or, intersections are and. We're not going to be using the intersection here, okay? Okay, so this portion of the graph, walking around and even on your quizzes, on the interval notation, just a reminder, you go from least to greatest. Okay, so, and when we read a graph, we read a graph from left to right. Okay, so what's the lowest value represented here? Yep, it keeps on going that way, so negative infinity. And then the upper boundary is 0, and it's going to have the same symbol there. And then the other part we pick up at 6 and go on up to infinity. Okay, you guys do this one. Check in with a neighbor, and then we'll chat. They shouldn't. I'll bet you didn't reverse an inequality. Okay, did you guys start the last one? Okay, so when we're solving the inequalities, you've got the compound inequalities, you're doing two problems kind of simultaneously. So just like we did up here, you'll start your problem with an or in between them. You'll do your work on this one, you'll do your work on this one, and at the end you'll state your solution with the and or the or in between them, or in this case. You don't have to write down the or every line you go along the way, but at the beginning and at the end. So when I'm writing these ones here, I'll say 3t plus 1 is greater than or equal to 10, or 5 minus 3t is greater than or equal to 14. There's my or. I don't need to write it again till the end, but it needs to be there. So let's see, subtract 1 and divide by 3. Let's see, subtract 5 and divide by negative 3, and that should raise a red flag in your head, because we're dividing by negative, so we need to reverse that inequality. And my line's got a little bit off, so I'm going to rewrite it at the end. Okay, so if we plot that, t is greater than or equal to 3, t is less than or equal to negative 3. It looks like that. And then to write the interval notation, how many intervals do we have? Yep. So this one starts lower boundary of negative infinity, and it goes up to negative 3. And then it starts at 3 and goes on up to infinity. Are there questions so far?
So when we wrote out the problem, or rewrote the problem, we don't really pay attention to which one is negative first. Doesn't matter. Like when you said greater than or equal to 3 or less than or equal to negative 3.
Yeah, because like in your work, you'll have two columns of work, and at the end it should state what you're come to. Like when you solve an equation, at the end you write x equals 5 or whatever it is. Same idea. You should put it all together at the end. Now, if your lines were off, you could just finish with this also. So you could skip writing it like this and jump to the notation. Would be okay as well. Question asked, do they ever overlap? Yes. And what we do with it, it depends. Okay? It depends on if it's an and or an or. So you guys will see some on Wednesday, actually. I told you we'll be using this content. You'll see some on Wednesday. Okay, so that's or. Ors tend to be a little bit, there's just less you have to think about because it's one or the other, doesn't matter. And though, there's more to think about because it has to be true for both the inequalities. So let's look at this. Okay. What I'm asking is for us to graph x is greater than negative 8 and x is less than or equal to 5. There's some forethought that needs to go into this, especially if you're using pen. Okay? Because when we graph this, our number line at the end should only have the solutions, okay? We can't use one color and another color. I'll talk about that in a second. Okay, so x is greater than -8. So let's look at them one at a time, what they look like. This is something eventually you'll probably kind of picture in your head or do a quick little sketch on the side to see what's going on here. So x is greater than -8. So -8 for greater than, so this one's going this way. X is less than or equal to 5. So we're going this way. So that's more something we'll do in our head. And then we have to ask ourselves, well, what does the graph of x is greater than -8 and x is less than or equal to 5 look like? Well, it's going to be where those two overlap. Okay? And so we're going to look at from here to here. Okay, so where is our graph going to start at? It'll start at -8, and we'll use the same endpoint. And it's going to end at 5. And it's going to include everything in between. So we should not extend our line past these endpoints because they're not part of the solutions. And that's what I see sometimes. I'll bring this out. This is what I would consider a sketch. Okay. I don't want to see this. I don't want you to see, well, -8 went like this. 5 goes like this. There's my graph. Whoever's looking at it should know I only want to look at where they overlap. No. Your graph should stop here and here. It shouldn't have the lines extending on the sides, okay? You've been warned. Okay, so, and typically are between two values like this. Okay? What would have happened if I asked you to graph x is greater than -1 and x is less than -3?
No solution.
Would they overlap at all? No, and so there would be no solution to it. So usually when we see an or inequality, a graph looks like this. There's two parts to it. I won't say always, usually. Okay? Sometimes they might look like this, and we'll talk about that on Wednesday. Okay? Actually, you'll see it on your homework. If it's an or, does it matter where they overlap? No. If it's an and, does it matter where they overlap? Yeah. And so typically, or graphs look like this, and graphs look like this. You know, you'll see it in your homework. I'll go ahead and talk about it really quickly. Where do I want to do it? Okay. So let's look at these two inequalities. They're both pointing the same direction, right? So when we graph them, they're both greater than, so it's going to look like this, right? These are my endpoints, by the way. My thumb tells me the direction it's going. Okay, so they both go like this. And so the and the or are going to have different results. Okay, so in my head, for this one, I'm thinking there's 1, there's 3, and they both go this way, right? In my head, or in Scratch, this is not a nice number line that's going to show your solution, okay? But it gives us an idea about what we're looking at. If it's or, does it matter where the number lines are? No. So for this one, my number line is going to look like this one. We're at 1. It's going to go like this. Now, it doesn't matter what happens at 2 because it's included inside of this one. As opposed to this one here, we do care. We look at where they overlap. Yeah. Where do they overlap? That's the 3. I know, I just noticed that. Okay. Where do they overlap? From 3 on out, right? So this graph would look like this. The and only includes where there overlaps. The or includes whatever, both of them. Okay. Okay. Now, what's your name again? Emma said, can we put the inequalities all together with 2 inequality signs and the variable in the middle? The answer is yes, if it's an and. Okay? And so those are called between inequalities or 3-part inequalities. Okay? And inequalities typically tend to be between 2 values like this. So when we're looking at this, we want to graph the interval -9, -2. So we're starting at -9 with a square bracket included and going to -2 with a parenthesis. To write this as an and inequality, we would say that x is greater than or equal to -9 and what?
Less than -2.
Yep, and x is less than -2. So that's how we'd write it with an and. But since it's between 2 values, we could use this 3-part inequality and say, well, x is greater than or equal to -9, but less than -2. It's between those 2 values. The inequality should face the same way. So if you have something that's an and like it's greater than 3 and it's greater than 7, we shouldn't write it like this. The inequality should always face the same direction. Okay, you guys graph these 2 and state the solution using interval notation. This one's an and, this one's an or. What? Yeah. A little disjointed. Are there questions about those? So and is where they overlap, or is one or the other, doesn't matter. Okay, a little more loosey-goosey. Okay, the last big thing that I want to talk about is 3-part inequalities a little bit more. Because sometimes we're going to write them like this, and we need to be able to solve them when they're written like that. Okay? Now, if it's a between inequality, it's this and or. and, because it's between two values. It's greater than something and less than something, between two values, okay? So and, okay? So we can solve it. It's just like solving a regular inequality, except for instead of two sides we have three parts, or sides. We can call them sides if it makes you more comfortable, okay? And so our goal is still to get the variable by itself, and we want to get it by itself in the middle, which is where it's going to start, okay? You're not going to have it start elsewhere. It'll always be in the middle. But there might be other things mixed in that you need to take care of. So let's look at this one here. 4 is less than t plus 2, which is less than or equal to 8. So we want to get t by itself. So, ignoring everything else, what would we do to get t by itself? Subtract 2. And so that's what we're going to do. And I'll go ahead and show all the steps for this one. But if we subtract 2 from the middle, we have to subtract 2 from the outsides also, all three sides, or parts. So what are we left with in the middle then? And that's what we wanted, right? The inequality signs stay the same unless we multiply or divide by a negative. That rule still applies. On the left we have 4 minus 2 is 2, and on the right we have 8 minus 2 is 6. Okay. And then as far as notation goes, this one starts at 2 and goes up to 6 for interval notation. This one's or equals to, so it's a square bracket. This one is not or equals to, so it's a parenthesis. And then the set notation. We get t as long as t is greater than 2 and less than or equal to 6. Other questions about that? It looks kind of weird, but it really is a pretty gentle leap from solving equations and inequalities, which you guys have been doing. We're going to do one more, and then I'm going to turn you loose, okay? Because this one's a bit more involved. Okay. Our goal, again, is to get m, this time by itself. So, looking at it, we were dividing by 2. So more efficiently would be to multiply by 2. So that's what we're going to do. I'm going to squeeze it in here. It's hard to write the multiplication in there. Okay, we're multiplying by 2. So on the inside, when we multiply by 2, what are we left with? The 1 minus m, And on the left, we're left with 2 divided by 2. Those cancel out, leaving us with negative 5. And on the right, 4 times 2 is 8. We're not done. We got to get that m by itself. What's the next step? The 1 is doing the subtracting. The 1 is actually positive, so we're going to subtract it. Okay? But don't lose track of that minus sign in front of the m. It's important. So we'll have to bring it down. So we're going to subtract 1 from all three parts. So negative 5 minus 1 is negative 6. Negative m. And 8 minus 1 is 7. Are we done? M's not quite by itself, right? How are we going to get it by itself? Divide by negative 1, or we can multiply by negative 1 as well. It's easier to squeeze in a divide by there, though. So I'm going to write divide by negative 1. Now we divided all parts by negative 1, so what do we have to do with our inequalities? We've got to reverse our inequalities. Negative 6 divided by negative 1 is 6. Reverse the inequality. Use this with an m in the middle. Reverse the inequality. you a second to catch up and then I'll talk about the notation. Okay, interval notation, what's the lowest value? Yeah, our inequality is written a little backwards now, right? So we gotta keep that in mind. So the lowest value is -7, not or equals to, and the highest value is 6. We go from -7 to 6. When you go to put it in set builder notation, we should write things least to greatest. And so you have to like take that whole 3-part inequality and turn it around. Okay? So when we go put it in the interval set builder notation, we're gonna put the -7 first. Just make sure that you reverse your inequalities. So you saw this one is pointing to the -7. When we turn it around, it still needs to be pointing to the -7. This one is pointing to the m, it still needs to point to the m. So take the whole thing and turn around, yep. Yeah, so watch out for the directions when you have to turn around an inequality. Are there questions? Okay. On the back, so we talked about that, and that's okay. Okay. Pull out your syllabi. So we're right on track. We'll do 2.5 on Wednesday. I might try and start 4.1 because next Monday we have a drill, evacuation drill, sometime between 10 and 11:30, which guarantees our class will be affected. Okay? So if you're printing out the notes, you might print out a day ahead, and anyways, we'll see. Okay? Homework is going to be 2.3 and 2.4. So I'd asked over the weekend for you to work on the practice problems. Should you skip graphically now? No. So go back and do those if you didn't already. Okay? Questions? Okay, email me with questions, you guys. I'll see you Wednesday.